This is the second video lesson, the last lesson for this week, and we're going to talk about solving exponential and logarithmic equations. We'll just begin this week, and next week when I'm back, we will solve some more difficult equations. All right, so let's just take a look at what this is. This is on page 210, if you have that copied off. So if a to the x equals a to the y, then x would have to equal y. That seems to make sense. The same with a logarithm. If the log base a of x is equal to the log base a of y, then both x and y would have to be equal to each other. Here's a couple of inverse properties that we've already talked about. A to the log base a, those are inverses, so they cancel each other out, and we just get x equals x. And the same if it's ordered this way, log base a of a, those just kind of dissolve each other, they undo each other, so x equals x. All right, so let's take a look at some of these examples here. We'll just run through the first couple examples. If we have 2 to the x is equal to 32, we look first to see, can we write this as 2 to some exponent? And it might take some punching some buttons on your calculator, but you can figure out that 32 is equal to 2 to the 5th. So now we have 2 to the x is equal to 2 to the 5th. So therefore, using this property up here, x would have to be 5, and you've solved that equation. Here we have log base 4 of x minus log base 4 of 8 is equal to 0. So that means if we were to add this over on this side, we would have log base 4 of x equals log base 4 of 8. And what we do something here, we call just drop the log, since they are both the same on both sides. So it's like this property right here. They're both the same, so x would have to equal 8. The same here, we'd add the natural log over, so therefore x would equal 3. All right, this one is a little trickier. If we have 1/3 to the x is equal to 9, again, we want to write these both as the same base. 1/3 x is 3 to the negative 1, and 3 to the negative 1 to the x becomes 3 to the negative x, and 9 is 3 squared. So therefore, negative x would equal 3. See, the bases are the same, so we can drop them. And therefore, x would equal a -2. Some little tricks here. All right, I'd like to write this one down because this is getting into more typical looking equations. So we have e to the x is equal to 7. So one thing that we can do to both sides here, we say, how can we get rid of this e? We can get rid of the e by applying the natural log to both sides. So if I natural log this side of the equation, I natural log that side of the equation, natural log and e cancel, and we would get x is equal to the natural log of 7. And you might wonder, what is the natural log of 7? Well, let me show you where that would be. Do you see the e to the x key? Here's the natural log key, and I can just simply plug in what is the natural log of 7, and it's a number. Okay. The next equation, natural log of x is equal to -3. Let's write that down. Natural log of x is equal to -3. Just like we got rid of the e by applying natural log, we get rid of the natural log by applying e. And we kind of slide it in here in the bottom because e is always raised to something. We don't take e times it. That's not how we get rid of it. E would be to the natural log. We call this exponentiating, where you slide a little number underneath. And these are the exponents here, perfectly valid mathematical thing to do. So that cancels, and we get x is equal to e to the -3. And again, if you wanted to know what e to the -3 would be, To access this key, we would do second E. Do you see how it comes up here? And then we could just put in -3 and enter, and there it is, 0.049787 goes on for a bit. All right, if you look on page 210, we have letter G, which is log base 10 of x is equal to -1. Two ways we could go about this problem. We could use the definition of logarithm and say that 10 to the -1 is equal to x. That's the definition. The base to the exponent equals the argument here. Or we could do like we did on this one and slide in a little base here, exponentiate this guy. Since I'm using log base 10, I'm going to use the base of 10 here. Otherwise, it wouldn't work out at all. So that cancels out, and we get x is equal to 10 to the -1, or that would be 0. Oops, no, it wouldn't. It would be 1, or 1. Yep, x is equal to 1. All right, and the last problem in that list, we have log base 3 of x equals 4. Since the base is 3, that's the number that I'm going to exponentiate both sides with, because 3 to the log base 3 cancels, and we get x is equal to 3 to the 4th, which is 81. Okay, let's go on to example 2 on page 211. Hopefully you had those pages scanned, right? And we have two problems here. E to the x is equal to 72. Let's try that first. Let's take a look at that. E to the x is equal to 72. And you'll start to see the pattern here. How do you get rid of the e? You get rid of the e by applying natural log to both sides. And now notice the slight little difference here. I know it's confusing because maybe you haven't seen this. When we have a logarithm, we want to get rid of it. We exponentiate. But when we have an exponential, we want to get rid of it. We apply the natural log to both sides. So the natural log is right next to it, because the natural log of e cancels, and we get x is equal to the natural log of 72, which is some number on your calculator. The second problem, 3 times 2 to the x is equal to 42. Well, what we normally would do, you know that this is not equal to 6 to the x. Don't do that. You cannot distribute that in there. Only the 2 is raised to the x, the 3 is not. So how about if we try and isolate this exponential by dividing both sides by 3, and I would get 2 to the x is equal to, is that 14? I hope that's 14. Now I can't write 14 as 2 to the something. 2 to the 3 is 8, and 2 to the 4 is 16. So we skip right over 14. So what I'm going to do then, can you guess? If you have an exponential and you want to get rid of it, you're going to do what to both sides? I hope you said apply log. And I'm going to apply the log base to. Any other log would not get rid of that 2. Boop. And we have x is equal to the log base 2 of 14. And you might wonder, what the heck is that? Well, that also is a number in your calculator. Now there's this thing, an old school thing that's called the change of base theorem. But if you have a graphing calculator, you don't really need to do that at all. I just wish I knew in advance. Oh, yep, there it is. So under math, see where that says log base? And I'm going to press that. And I can just put in whatever base I want and whatever number I want. So I want to find the log base 2 of 14. I'm going to put in the 2, and I'm going to put in the 14, and voila, there's our answer. All right, your homework for this section is on page 217. I wanted to skip over there. And you are doing 23 through 53 odd. Seems like a lot. I don't think it will take you too long. Just wanted to take a look at some of the even ones then. 3 to the x equals 243. Well, you could just log base 3 both sides, or you could know that 3 to the something is 243. Is it 3 to the 5th? I'm guessing. Ah, yes. So you could write this as 3 to the 5th. So 3 to the x equals 3 to the 5th. X would be 5. All right, this one should be easy to do without the calculator. 49 is 7 squared. So 1 over 7 squared would be 7 to the negative 2. So we have 1 over 49 is the same as 7 to the negative 2. So then we have 7 to the x equals 7 to the negative 2. 7 to the x equals 7 to the negative 2. And drop your bases, so x would equal negative 2. Now, obviously, as you go on a little bit, they're going to be a little bit complicated. But do you see this? We're going to work this one the same way that we did that previous exercise, divide both sides by 5. For this one, I believe 256 can be written as 4 to a power. What would you do here? Number 40. How would you solve that? How do you get rid of the natural log? You want to exponentiate both sides. You put the little e down there. All right. Oh, this one's interesting. How would you do this? I think what I would do is I would use the definition of logarithm, and I would go x to the 2, x squared equals 81. Then that's pretty easy. You could do this here as well, 10 to the negative 1/4. How do you do 10 to the negative 1/4? Well, you do have this 10 to the x button, which you could use. 10 to the negative 1 divided by 4. Whoopsie. And then enter, and there you go. That's 10 to the negative 1/4. So I hope you know that there are several different ways that you can solve these. So just go for it. Have some fun.